Next, we discuss a maximum power transfer. We know that in the resistive circuit, if the internal resistance of a voltage source is Ri, and the outside load RL is a variable resistance, then the load would gain the maximum power when RL equals Ri, and the maximum power is US squared over 4 times Ri. How to expand the conclusion to the SSS of the dynamic circuits? We need to assume that Zi equals Ri plus Jxi, and ZL equals RL plus JXL. So we can find the current phasor. The effective value of the current is. So we can know the active power absorbed by the load is. Do you find if the resistance and the reactance part of the load are variable, then the power is a bivariate function of RL and XL. Similar to the analysis of the resistive circuit, we can find the necessary condition when the bivariate function is extreme, that is, solving the equation, we can get the condition when the load obtains the maximum power is. We can also verify the condition is a sufficient condition for load obtaining the maximum power. Combining these two conditions, it can be written as, that is to say, when the load impedance is the conjugate of the internal impedance of the power source, the load would obtain the maximum active power. The value of the active power is. We call this kind of condition conjugate match. In the following study and exercise, we can directly apply the condition and the conclusion. Well, that's the end of this lecture.